All right, well, let's get started. Hi, everyone. I'm Don Schwarz. This is Toby Reyelts. And we're here today to talk to you about Java support for App Engine. So the goal here is really to bring you up to speed for all of the new features and improvements that we've made over the little over a year since we launched Java support. Before we get started, I just want to remind everyone that you can go to this URL and view live session notes, and you can ask and vote on questions on Google Wave. All right, so here's what you can expect from our talk today. We're going to start with just some quick statistics, a quick overview of how we've grown over the course of the year. And then we're going to spend most of the time doing a demo and introducing a demo and doing a deep dive into the code after you guys see it. And then we'll talk about some additional improvements we made, including some behind-the-scenes improvements to performance and compatibility. So we now host over 100,000 Java applications on App Engine. So this is primarily web apps, but we also have backends for Android and iPhone apps. We have open social apps, Facebook apps, Wave robots, chatbots, et cetera. And that's approximately 1/3 of all App Engine apps. So I think that's pretty good evidence that when you consider that Python had about a year head start on us, both languages are very important to us and grow at a pretty steady rate. We serve thousands of hits per second in a pretty much steady state. But we also have a number of applications with very spiky traffic patterns. So the example you see here is something called Gig Socialize, which is something we've highlighted on our blog in the past. And they do basically a chat service that is often advertised in television advertisements. So they have very spiky traffic. And what you see here is actually a graph taken from their admin console that shows them ramping from basically no traffic up to about 1,600 hits per second over the course of just an hour or two. So I think that's really good evidence that we can absorb large traffic spikes on your behalf, which is one of the big benefits of App Engine.
So Don and I spent, is this thing on? There we go. So Don and I spent a lot of time trying to figure out what was the best way to introduce all of these new features that have kind of accumulated in App Engine over the last year. And one thing we learned from our session, our I/O session last year, was that people really enjoy good fun demos and getting deep into the code of those demos. So we decided why mess with success? So we're going to do the same thing this year. We've got a game that we're going to have you all hopefully participate in if the Wi-Fi cooperates, and we're going to take a deep dive into that code. So let's pull that up. We have wave questions already. So this is a game we like to call Dance Dance Robot, and kind of the way this game works is that you have this Simon robot. It's kind of a mix between Simon Says and between memory, and this robot right over here, he makes dance steps. He moves his limbs, and your goal as a player is to repeat those same dance steps in the same order. As you can see, the URL here is dance-dance-robot.appspot.com. So if I come in here, I'll just enter my name and then join a game. So when I do that, it goes and it looks for a game. Looks like a bunch of people have already joined in with me. So you can see that it dynamically picks up other players. There are a max of like 8 players in the game. And so here the robot is doing its dance. So I'll do the dance too. And then if you do it right, you get a happy robot and you get some points. If you do it wrong, well, we can kind of see Don up there. His robot's really sad. Don didn't get the dance right. So we'll do a few more of these rounds. One really cool thing about this is this is real-time push, what you're seeing, right? As everybody else in the audience and Don here and everybody is making their moves, those moves are being broadcast to everybody in the game. And some of you may actually be playing the game and you're in a different game, right? And you'll see other participants in the audience playing with you. Oops. I wasn't paying attention. I just missed that one too. as the rounds go on, the game gets harder. We add more dance steps and things like that go on. I'm really bad at this. I can't play and talk at the same time. I don't think I'm going to win this. Looks like maybe Brindy is going to beat us all. We actually tried to set this up for the demo so that it only took 5 rounds, but I guess we didn't quite get that right either.
Someone else beat us to it.
Yeah, somebody else beat us to it and started a 10-round game. So you'll just have to suffer through it. Sorry. I could talk a little bit more about this, actually. So Dance Dance Robot is actually a GWT app, a Google Web Toolkit app. And of course, the back end is App Engine. And part of the push API I was talking about earlier is a new API that we've actually just released. In fact, we just got it out to production servers very, very recently. So we were up to the last minute making sure this all would actually go for I/O. So I'm very happy to see like alarms and bells and whistles aren't going off here.
Do you want to go into the code and then come back?
We're almost done. 2 more rounds. So Don told me while I was working on some of the icons, that he had first come up with. I drew the sad robot, the sad android, and he told me, "Man, that sad android doesn't look as sad as it looks creepy." But we didn't have a lot of time to change that, unfortunately. We also had a big tiff with the Android guys. They were like, "Man, we love that you're using our Android logo, and that's really awesome. But you can't call the game Dance Dance Droid because Lucas will get really upset, and you can't call it Dance Dance Android because then all our partners will get really upset too." So we lost 2 of our favorite game names. All right, so the 10 rounds are over, and you can see what happens at the end of these 10 rounds. Like the scores have been calculating and everything like that, and what's happening on the server is we're generating the award, and so I got 5th place, which is not so great. You guys in the audience, who I think Brittany was 1st place or something like that. So there we go, that was our demo, and now we'll actually jump into the code for this. I'll take applause if anybody wants to applause. Thank you very much. So like I was saying, this is a Google Web Toolkit application, and actually, I take it back. I'm going to jump into slides first and talk about the channel service. How about that? And I'll give you guys just a little bit more background. We'll talk about the design and things like that first. That'd be a better order, I think. So here's the game design. As I was saying, it's a Google Web Toolkit app. We actually use 2 transports to talk to App Engine. The first is typical GWT RPC, and GWT RPC is just XML HTTP requests to the server. We make all our outgoing requests to the server via that transport. The second transport is the channel service, and that's a new service I was talking about that is a push-based service. So all of the messages from App Engine that we want to push to all of the different players during the game, that goes across the channel service. Whoops, wrong direction. So on the back end, we make heavy use of the task queue service. And the task queue service has been around for like 6 months or so, new since last year. And basically what that lets us do is it lets us run a lot of background game logic asynchronously. So anytime in our code, like on the server, where you would write code and you would want to block for a response or just wait, instead we fire off a task, right, and do that in the background. And then we make use of 3 different storage services on the back end. So there's the Datastore and Memcache and blobstore. In Datastore and Memcache, we use those guys in tandem, which is typical. We store our game state in there, and then we cache it additionally in Memcache. We talk to the Datastore via JDO. There are lots of ways you can talk to it. JDO, JPA. There are like 3 different third-party libraries out there that are pretty prominent, like Objectify and SimpleDS and Twig. We use HTTP sessions, and those are transparently backed by both of those guys. And then there's blobstore, and the way we use that is that award certificate you saw in the end was dynamically generated. So that's kind of like a large image, or a couple large images that we store in blobstore, and then we dynamically scale it to the size of your screen and render the place and the player text over that. And blobstores. So in general, the point of blobstore is that you can store really large objects and receive them and serve them out. So let me talk more about the channel service, since that's really like a really new feature. So it's push messaging and it's over HTTP, but it's actually bidirectional. So if you've ever heard of like hanging gets or like Comet or even like WebSockets is coming along, right? You're pretty familiar with this style of communication. In fact, I think we have plans to actually make the channel service interop with WebSockets later. The way this works on the server is we have a channel service API, and that allows you to send messages. And then you receive messages from clients in a webhook. So the same way that you would get like email messages or that you'd receive XMPP messages, you get those in a webhook with the channel service too. On the client side, what we have is a JavaScript library. And so it's a web app. You take this JavaScript library in your web app, and has an API that you use. And it looks pretty similar to the server API. But instead of having a webhook, which doesn't make any sense on the client, you have JavaScript callbacks to receive messages from the server. And finally, the channel service is built on the Gmail chat client, which runs on Google Talk. And the benefit of that is that it's already scalable, it's already well tested, and so you're building your code on services that have been around for a while. So here's the server API with a funky indented comment. This is what you would program to on the server side. There are 3 basic functions here. The first thing you would do to communicate with clients is to create a channel. And you do that by specifying a unique application key. And that application key is just an identifier you come up with that identifies that channel. Once you pass that in and you get a response, the service has created a channel for you, and it returns an ID that is a client-side channel ID. So that ID is what you will pass to the client, to your JavaScript app, right, to have it connect to the channel. After you've created a channel, then you can send messages on the channel. You pass a channel message object, and the constituent parts of this are the application key that you specified to create the channel in the first place, and then the actual message contents that you want to push to the client. Now, the channel service only lets you send strings directly, like UTF-8 encoded strings. So you can't, by default, send objects over the channel service. Instead, it's string data. And finally, you receive messages, like I said, on a webhook in the channel for the channel service. And what you have to do is you have to parse the data out of the HTTP servlet request, similar to the way you would do that for email or whatever. So that's what the parse message function's for. Now let's talk some about the client API. Like I said before, it's implemented in JavaScript, but we also plan on providing a Java wrapper around that for Google Web Toolkit applications. And here's some sample code of what the API looks like. First, you create a channel, and you specify that channel ID that I talked about that was returned to you on the server. So you get a channel object back, and then you open that channel object, you get a socket, and that socket is how you communicate on that channel. There's an on-open callback. That callback is called once the channel has fully been established, once your communication has been established there. So you can act on it at that point. And then there's the onMessage callback, and that's called every single time the server pushes a message to your client. And the event.data there is the string data for that message. And then finally, sending a message is really simple. You just push a string in there, and boom, it goes to the server. Guess I could have highlighted those as I was talking about them. So the task queue service. This is kind of new. Like I said, it's about 6 months old, but we'll go quickly over some of the features. It allows you to do work in the background asynchronously and dynamically. So instead of you can create like task queues on the fly and tasks on the fly in response to whatever. You can have up to 50 requests per second on tasks, and bidirectional is wrong in that slide. This works in the dev app server. This is fairly new. What you're able to do is you're able to take you're able to schedule tasks like you would in a real server, and they'll automatically execute, which is pretty nice. So you get the same behavior as you would in prod. You're also able to see the tasks and execute them manually if that will also help you out in your testing. Something else that is also fairly new is that tasks can participate in Datastore transactions. And so what this means is that when you go to add a task in a queue, if you have it participating in the transaction, then that task won't get executed, for example, if the transaction gets rolled back. OK, so before we go and talk about the blobstore service, let's dive into the code of the application that actually makes use of the channel service. So I talked about it being a GWT application, and we have our RPC, our GWT RPC service right here, and it's called the game service. And the game service has a few methods. There was the original login screen we saw, and then we have something that's a confirm login. So after we've established communication on our channel, then the client confirms that they're ready to receive messages. And then every time you take a step, the client makes a call to the server to let you know that a step's been taken. So let's dive into the implementation of login here. So you can see that we go in, reserve a game, and then we're doing some work here with the HTTP session and so on. Then we're starting a transaction and then adding you as a player to the game. And let's get a little bit further down here so we can talk about the channel service. So right here we have just a small little abstraction we call the push server. And if we follow in to the create channel call, and we pass a player in here, you can see that we're just using the same channel service API I went into the slides just a moment ago and calling that create channel function. And we're just passing in a key that's the player key. So basically each player gets their own channel, right? So that's all really pretty simple. And then the channel ID that comes back from there is returned from this function. And so if we come back up, there it is again. And then in our login results, what we do is we return that channel ID. So these login results go back to the client, and the client has that channel ID that it can establish communication on. So if we let's follow into the client code and see its side of that. So this is like the main class. This is it's the entry point for the GWT application, and there's actually a find game panel, and this is the login screen basically. So after login successfully happens, it calls back into the main panel and it calls this login complete function, and we see basically about the first thing we do here is we create a client side channel, right? And it's using that channel ID that came from the login results that was returned from the server. So this API looks a little bit different from, we saw that was a JavaScript API before, but this is Java code. Well, let's dive into the guts of this create channel call. So what's going on here is this is taking advantage of GWT's JavaScript native interface functionality. So this is the JavaScript right here, which looks like the code we saw. It's just creating a new channel and just passing in the ID. And so it's really just a thin wrapper. And if we looked at the other classes related to this, like, let's see, like the socket listener and things like that. Well, socket listener doesn't have any code. That's not useful. But But in general, all of these are just a really thin wrapper around the JavaScript API. So just straightforward. So what we do here on channel.open is we're establishing communication. We're establishing a socket, and we pass in the socket listener. And there are 2 callbacks on the socket listener. The first is onOpen here, and the second is onMessage. And like we said, onOpen was a callback that occurred when the channel communication was established. So when we know that the channel is established, we call an RPC to the server. This is the confirm login. So we're making a call back to the server, letting it know, hey, the channel's up. We're ready to receive messages from the server, right? And then the server responds and sends us a bunch of messages that tells us which players are already in the game. So that's what's going on right there. And then in onMessage, this is the other callback that's called every single time the server pushes a message to us, right? And I talked about this just being a string, and we can see that that's what I'm receiving here is a string. But we're doing something pretty tricky and neat here, which is that we're taking advantage of GWT serialization to encode objects into strings. So this is a little bit of magic, a serialization stream reader. There's a corresponding serialization stream writer on the server side. And that encodes the object into a string, and then we push that string on the channel API, and then we decode it here. And so you can see what we get back is this message object. And if we follow into the message object, you can see it has a, let me turn on something here so you can see it on the left-hand side. Auto scroll to source and from source. There we go. So you can see that there are actually several different kinds of messages here, and these are all subtypes. And we get the correct subtype that was serialized across the channel. Somebody's trying to call us. So that's basically it for the channel service. Let me go back to the slides here. I talked about the task queue service, so I think we're ready to talk about blobstore.
Do you want to put in a quick plug for the deferred library?
Yeah, let me do that. That's a great idea. Before we go on to blobstore, let me go back into the IDE here and talk a little bit about the code around the task queue service. So let's go back into the login, the implementation of that login method. So we saw here that we were creating a channel and things like that. Well, here's what Don was saying is that there's a third-party library called the deferred API. And this is a library that's written by Vince Bonifanti. I hope I'm not mangling his name, which simplifies a lot of the task queue API. So if you're doing some simple stuff with task queues, it's a great API, and we're actually considering it for inclusion in the SDK. We'll have to do some code review and some tweaks, and we found some bugs along the way, but we hope it will make it. So if we follow through to this API, we can see that it's pretty simple here. There's a defer method, and you pass it a task and some options. Well, let's ignore the options for now. Those aren't really important. But the way this works is that deferrable is an interface with just a single callback, do task. So this is where you would do work in your task, right? You just implement this interface, and you do your work. And I can actually show you that. So we have send new player is an example of a deferrable. So when we defer an instance of the send new player object, Vince's library, the deferred library, does all the work of actually creating a new task and adding it onto the task queue. And it actually ends up serializing these objects. It ends up serializing the send new player object into memcache or even in the Datastore if necessary. And then when the task executes on the task queue, he calls back through to our object and calls the do task method. And so in here you can see we're just getting a list of all the players in the game and then just sending a message out with those players. And then we have a few more examples of those tasks here, like dance begin, where we do significant amount of work, and then the start game task. I think that's a pretty good coverage there. Oops. Set you up the bomb.
There we go. OK, so now let's talk a little bit about the blobstore service. So Toby mentioned earlier that the certificate image thing you saw at the end was powered by blobstore and the image API. So let's talk a little bit more about what blobstore is. I know a lot of you are probably familiar with it. I think we launched it back in December. But it basically allows you to upload and stream large files. So in App Engine, we tend to pass requests and responses around as atomic units. And that's one of the reasons that those are limited to 10 megabytes right now. But we know that's not enough. We know occasionally you need to be able to have your users upload large files and to stream them back to users. So we basically implemented a separate infrastructure that handles streaming uploads and downloads specifically tuned for large files. So the way this works is that you get a one-time use URL for uploading, and you just submit an HTML form with file elements attached to it. And we handle all of the upload and the persistence of that blob and tracking blobs over time. And we give you a callback whenever a blob is added that contains a reference to that blob. So once you have a reference, you can either serve it back to users in a streaming fashion, or you can retrieve chunks of it at a time and process it within your application code. And finally, the images API has been modified to take blobs as input data. So this is very useful, for example, if you want users to upload profile pictures. They may have just taken it off their digital camera and not really have a sense for the fact that it's a 5 megabyte image. This allows them to upload it to blobstore, and then you can still thumbnail it down to a reasonable size for storage in your application. So let's take a quick look at the application code that actually implements this. If we pull up, so before we actually started this demo, I uploaded that initial template for the award certificate at the end. That wasn't the one I was planning to use, to be honest, but it worked. And so I uploaded it through this admin-only JSP you can see here, which is just really trivial. All it is an HTML form with a file element. The one App Engine specific point here is that we're making this create upload URL API call to get the URL for it. And this string we're passing here is the URL where we want to receive our callback. So if we take a look at the servlet that actually implements that URL, you can see here that it's basically just making another API call to get the uploaded blobs. This is getting the reference to the blobs from the callback. There was just one of them attached with this name. And then we basically have some boilerplate JDO code here, which attaches it to a JDO entity and persists it to the Datastore. And then finally, at the end, it redirects you. You always have to redirect at the end of a blobstore callback. So in this case, we redirect to the servlet that actually provides that back to the user just for testing purposes. But this is the same servlet that's used to serve that image up at the very end of the game. So if we take a look at that servlet, it's basically very simple. It's just querying that award object back from JDO. It takes the blob reference out of it here and makes it into something the image service knows about. And then it makes a set of image API calls here. So we can see that we're resizing the image to a reasonable size, and then we're compositing some other images on top of it. And what those other images actually are is the dynamic text of your name and the place that you received. Now, the image API doesn't support rendering of text, at least right now. So what we did is we actually found an open source library called LightText, which is on Google Code Hosting. That was actually, I don't know if it was specifically written with App Engine in mind, but it's promoting that it's supported on App Engine in Java. And it emits bitmap images for the text, which is something that the image API supports as its input source. So we were able to very simply render the text into a bitmap and then composite that directly on top of our award template. And then at the very end, we just stream the data out to the user. It was just that simple to build everything on the server side. Great. Oh, and actually, I can just show you what that looks like here. So this was the servlet directly emitting an image back to the browser, and it's pretty quick. OK, so let's go back to the slides here. So we also rolled out a diagnostic tool this year called AppStats, which makes it very easy for you to profile API calls that are used in your application. So later in the talk, we're going to talk a little bit about loading requests and the work that we've done to try to speed up loading requests. But putting loading requests aside, the majority of your time, unless you're a very CPU-intensive application, is going to be spent in API calls. So it's very important that you have transparency into what API calls you're making, and you can make tweaks to them. In last year's talk, I talked through the API calls that were involved, or the layers that were involved in an API call, and pointed out kind of the one central piece that all API calls flow through is a class called the API proxy. And we actually showed you some sample code that installed an API proxy delegate that gets a callback whenever an API call occurs and can basically log data about it. AppStats basically takes this to a whole new level. We have a servlet filter that's very easy to install, which manages an API proxy delegate for you, does all the hard work, and it stores all the data to memcache. And then we also provide a servlet that takes that data out of memcache and renders it in a nice graphical way. So we actually have AppStats installed on this game and was running the whole time you guys were playing it. Maybe some of you are still playing it, I'm not sure. But if we bring up the servlet here for AppStats, we should be able to go into one of these arbitrary requests and see what it's doing. And that one's not terribly interesting, it's just doing a query, but most of these should be making several API calls. That one didn't make any. But yeah, okay, so there's one you can see where we made 2 channel API calls and then a task queue call at the end. So you can see that in this case, we spent 234 milliseconds out of 238 milliseconds in API calls. So that sort of proves the point I was making. We also track the request and response data and the call stack for each of these API calls. So you can dig a little deeper and find out what's really going on. Okay. So that's it for the demo. Let's talk about some additional functionality that we've added over the course of the year. We made a number of Datastore improvements. Probably one of the biggest ones is support for cursors, which allow you to pick up a query where you left off in a previous request. So that makes it very easy to page through large data sets across requests. As part of this, we've dropped the 1,000 query limit. So you can now, the only limit to how much data you can query is your overall request deadline. We added bulk ID allocation, which makes it feasible to upload large interdependent sets of data, and our bulk import tools take advantage of that. We also allow you to choose eventual consistency over strong consistency for your queries. So if you can tolerate stale data, this allows you to have faster and more reliable queries. We track and store statistics about your Datastore data. Primarily, this is so that we can give you more transparency in your admin console into where your storage quota is going. But you can also query these things programmatically. So it's possible to find out estimates of the total number of entities in your Datastore in constant time. And a huge number of JDO and JPA improvements. If you tried it last year and you ran into some trouble, definitely try it again now. It's come a long way. We've made a number of improvements to the URL fetch API. Deadlines are now configurable. So in addition to the standard 5-second default deadline, you can now increase it up to 10 seconds. And in the future, we hope to increase that as well. And we added support for asynchronous URL fetch API calls. So you can fetch up to 10 URLs in parallel. We don't give you callbacks when they finish. What we do is we have this future-based API that wraps around the eventual result, and you can either block or poll on it. And the infrastructure for this is just general infrastructure that works for all APIs, but the URL fetch is the first API where we're actually exposing this directly to user code. But we expect to do that more in the future. Last year, we talked about how App Engine was especially well suited for web applications, but that we were going to add more support for webhooks to make it more powerful in the future, and we've definitely kept that promise. In addition to task queues, which we talked about, we also have support for an XMPP API, so you can send and receive messages. You can receive incoming email. And we're very happy that the Wave team provided a new API which allows both active and passive Wave robots. What that means for you is that you can receive a notification that a Wave changed as a webhook, persist some data to the task queue, do a complex calculation offline, and then come back and update the original Wave once your calculation is complete. We also added support for kind of first-class support for unit testing. So we now have an App Engine testing jar that contains a subset of the dev app server, basically just enough functionality to discover API implementations on the class path and route API calls through to it. But it also contains a set of test config classes that lets you configure each API. So for example, we will disable disk usage of the Datastore by default, because you don't generally want that in a unit test. If you want to know more about this, Max Ross is doing a talk, I think in this room later today, that's going to talk about this in more detail, I believe. OK, so now let's talk about some behind-the-scenes performance optimizations we've made. We know that loading requests are very important. They're probably much more important on App Engine than they would be in another Java hosting environment, where you're not necessarily dynamically rebalancing and reloading applications across many JVMs. And for that reason, a lot of Java applications or Java libraries aren't really optimized for low startup time. But despite that, we think we've made a number of things that help apps across the board and have really improved loading request latency. And we have a lot of additional ideas for big improvements as well. So one of the big things we rolled out this year was precompilation. And we haven't really talked about this much in the past, but when you deploy bytecode on App Engine, we need to process it. We need to be able to look at that bytecode and see what you're doing. And we do this for a number of reasons, but the biggest reason is to enable applications or libraries that would otherwise not run in our secure environment to run on App Engine. We need to maintain compatibility, and this is one of the ways that we do it. So we used to do this dynamically. When we would load a class, we would immediately process the bytecode. But that contributed to some slowness during loading requests. So since a couple of SDK releases ago, when we turned on precompilation by default, what we basically do now is to process all of that bytecode at deployment time. So this not only saves us time during loading requests, because it's not work we don't have to do then and don't have to do redundantly, but it also gives us the opportunity for more expensive optimizations. So we're experimenting with things like building stack maps if your bytecode doesn't already have it, or building jar indices that map out how your code is laid out across multiple files. Or even something as trivial as changing the the compression level of a jar can have a big impact. So these are things that we now have an opportunity to do behind the scenes as you deploy your code. So how does this work? Well, the SDK is already responsible for uploading a set of application files and their checksums to the server, because the server needs to know which files it hasn't seen before and request the actual contents from the SDK. As part of this, we also identify which files are likely to contain bytecode. And we break those into chunks of roughly equal work and send those chunks back to the SDK. And then the SDK just iterates through them sequentially, compiling them one at a time. So there's lots of opportunity for more parallelization and improvements here, but we just did something as simple as possible. But one really interesting requirement of precompilation is that we occasionally need to reprocess the bytecode for all applications. For example, if there's some new method that we need to be aware of or some new optimization we want to roll out, we need to process code for all 100,000 Java apps. So you might think that would be really slow and a lot of work and slow down our release cycle, but it turns out that we only need to process each unique file once across all apps. And luckily, many Java apps share most of the same Java libraries, so it's really not that much work. The last time we had to do this, the total amount of bytecode we processed was only about 35 gigabytes, which, when you consider we're using standard Google tools like MapReduce and stuff, is really not even enough data to register. So here's some of the results of precompilation. What you see here is the loading request latency before and after we rolled out precompilation, split up into a few different categories. There's time spent in application code, there's time spent in API calls, garbage collection, hotspot compilation, and then finally the red line at the end is bytecode processing, which is what we were really targeting here. And you can see that for most apps, including a sample ORM app and a couple of real-world apps I grabbed here, we completely eliminated bytecode processing, which was about 30 to 40% of the overall request time. But for other apps like JRuby and Rhino and similar dynamic languages, we didn't eliminate it. We only reduced the bytecode processing time. And the reason for that is that these libraries, like many Java libraries now, generate bytecode on the fly or instrument bytecode. So we still need to be able to do this processing of the bytecode on the fly. We can't predict every class that you're going to try to load at deployment time. And that's why you see there's still some red at the end after precompilation is enabled. But at the very least, we've eliminated all the bytecode processing for the language runtime itself and any dependent libraries like ASM or bcell or those sorts of libraries. So it was still a big win all around.
So, hello? Hello? There we go. That's not bad. So I'm going to talk about some of the reflection optimizations that we made specifically. So we had a set of big improvements that basically fell into two categories. The first was caching access checks, and the second had to do with failures. And so the deal with caching access checks is that they turn out to be really expensive. And the example I want to talk about specifically is a sample Grails app. So what happened is Graham Rocher, who is like a Grails lead, handed us the sample Grails app, and he said, What can I do to speed this up? Or what can you do to speed this up? And so we started doing profiling on this app, and one of the things we learned is that in the loading request, it was making 11,000 reflective calls. And if you know anything about Java, then you know reflection is like pretty slow compared to like normal method calls to begin with. And as we looked closer at that data, what we saw is that 50% of those reflective calls were actually only being made against 3 different methods. And so the good thing about that is that means that we could put together a cache that would cache the checks against those methods, and it would be extremely effective. And it was, and it turned out to be great. In the second case, what we learned about failures is that some reflective invocations they fail very slowly. They have to go through a bunch of checks, and as they go down each check and you do all this passing, you can end up just doing a lot of work when it comes to a failure. And an example here is the JRuby runtime. We've been working with like Charles Nutter, who is like a JRuby lead, and trying to help speed up Ruby loading requests. And what we found, for example, is that there were cases where it was making reflective calls like set accessible against object.finalize. And if you remember object.finalize, it's a protected method on object. So we don't let applications grab that method and do stuff with that. But the problem was that JRuby was doing that hundreds and hundreds of times on startup. It just would repeatedly fail over and over again and not realize that it was doing that. So there were a few things that we could do on our end to help tweak that. But working together with Charles, we were actually able to improve the JRuby runtime itself so that it doesn't do those failures both on or off App Engine. So in general, with these performance improvements we made, we were able to speed up startup to make it about 10% faster for most dynamic language runtimes. So there's Groovy and JRuby, but there's also Rhino and other runtimes like that. Here's a graph of some of the performance improvements we specifically made. You can see that in some cases, some of the improvements were modest, but in other cases, like calling string.index of reflectively, it was like an order of magnitude improvement. And yeah, actually, so the gray bar here, the gray bars are the old times, and the blue bars are the new times, and these times are actually microseconds. So, we're optimizing on the microsecond level here to bring you faster startup times on App Engine. And yeah, you can see set accessible where JRuby was doing a lot of calls is faster. Here's a second graph with some more times here, and what I'd point out is one of these. We couldn't like make the graph very well. We could go like exponential or whatever, but then things wouldn't look quite right. Anyway, we optimized something that was that took 20,000 microseconds all the way down to about 200. So that was 2 orders of magnitude improvement, which is we're pretty happy about, and shows up in the end. So let me talk more about future performance improvements to App Engine that we're working on right now. The first set of improvements have to do with reducing I/O latency, and which also translates to API call latency too. So if you have like really short, fast API calls right now, there's almost like a constant overhead to those API calls in general. And so a memcache call, for example, might be a fast call, but due to this I/O latency constant overhead, it has a pretty significant impact. So when we roll out this change, you'll see, for example, memcache calls improve in performance by a pretty hefty percentage. And in general, any I/O you're doing will have less latency to it. Another thing we did is that we're reducing the time spent in JIT and garbage collection overall. And when I say reducing it, what I really mean is that we're improving the parallelization of that work such that it all happens concurrently, and therefore you spend less time blocking in it. So the same amount of CPU time will take place, but it'll be happening on more processors, and so therefore your app will be loading and running faster for all intensive purposes. The last improvement I'd like to talk about are reserved instances. And like Don mentioned before, we know that a lot of people have been having pain with this, and the pain is typically for people who aren't getting, who aren't getting a lot of traffic. But we know that there are a lot of people using App Engine that don't get a lot of traffic, and it's important to help our customers out. And so we've been working very hard, and we have a plan. Unfortunately, we can't quite give you all the details about it since we're still working on it, but let me give you some of the highlights. The first is that, yes, you will actually be able to dedicate JVMs, and yes, that will reduce your loading requests. The second thing is that because you're dedicating a JVM, that means that JVM is going to be in memory like all the time, right? And that's actually a cost to us. In general, we've tried to make App Engine fit the philosophy that you only pay for what you use, right? Well, in this case, you're using more memory, so unfortunately, you'll have to pay a little bit with that. But we are doing everything to make those costs very reasonable. And so we hope to give you good details on that soon. And then the third thing is that as we give you the capability to dedicate, to reserve these JVMs, what we're also going to do is improve the admin console to give you greater visibility into how App Engine is actually spinning up and creating JVMs and things like that for you. So you'll be able to make good decision making around all of this. So now we're done talking about performance, and we'd like to talk some about compatibility and how we've been improving that. If you've been watching and been using App Engine, you'd notice that our top issues over the last year in terms of compatibility, in terms of JRE compatibility, has been around XML. Everybody uses a lot of XML on App Engine, apparently. So we worked very hard to bring those libraries. And the good thing is that not only can you now use all these built-in XML libraries in App Engine, you can actually even bring your own. So for example, if there's a newer version of one of these third-party libraries, then typically those will work out of the box for you. We also whitelisted a few additional classes that were causing problems with third-party libraries, and then we whitelisted a lot of classes that were causing problems in terms of serialization, which also improved compatibility. Here's a slide that just lists all of these libraries that, as far as we know, did not work a year ago and do now. And this is far from exhaustive. We just wanted to give some good examples of a lot of libraries that are now compatible with App Engine and how we're working very hard to continue to improve compatibility. And we'd like to take all the credit for this, but the truth is that in general, I would imagine there are probably people in the audience here who have done a lot of work issuing bug reports and talking to the people who work on these libraries and maybe even submitting patches. So what we'd really like to do is give thanks to the open source community for working very hard with us to make libraries compatible with App Engine. Finally, I'd like to talk about Dev App Server Sandbox emulation. And this seems like a little odd slide to put in with compatibility, but what's important about this is that as we improve the emulation on the Dev App Server, it helps you feel confident. You don't have to go up to the production server all the time to make sure that your libraries are compatible and whatnot. So we thought we'd talk a little bit about that too. One new feature is that we're doing very good at enforcing the whitelist now. If you've been using App Engine since it started, there were a lot of classes that you could use in the Dev App Server, and you really had to take your app into production to have any confidence at all that you weren't using something that you weren't supposed to. But that works well now. We also, in addition, do better enforcement around reflection. So so a lot of the things that you can't get away with on the App Engine production environment, you now can't get away with it on the Dev App Server. And in fact, we generally improve this stuff so well that there are now very few complaints at all about any security differences between the local and the production environments. So let me talk a little bit about how we do this. What we do, again, if you've been paying very close attention, there's a little Java agent flag that now gets specified with the Dev App Server. And what that is doing is that causes a JVM agent to be loaded up with the Dev App Server, and that JVM agent then instruments all the bytecode coming out of your web app, similar to how Don was talking about precompilation for production. So you can kind of think of it as like mini precompilation for your Dev App Server. And it goes in and it injects little bytecode hooks that like modify like effectively the runtime and makes the app conform to these checks. So does that mean the dev app server is a perfect emulation? Unfortunately not. The Google production environment is so different than the code that runs on your local machine that we probably will never have everything perfect. That means that it's still a good idea to every once in a while upload your app during development up to production and see that things are behaving as you expect. And then I guess that brings us to the end of our talk. So here's a little resource slide. We want to point out that you can hit the Dance Dance Robot demo and try it out for yourself if the Wi-Fi prevented you from doing that today. The source code is on code.google.com. We do want to let you know that since features it's using are so new to App Engine, they may be disabled after the demo for a small period of time, which will bring down the app, maybe for a day or something like that. And I guess we're ready to take questions.
Sure. Yeah. So should we start with, since there's no one lined up, you want to start with moderator, and then we can switch back and forth. All right. So what's the new comment support in App Engine going to be like? How do you build efficient applications with always open comment connections? So I think we've answered that throughout our talk. Do we want to say anything else about it?
You could talk a little bit about the efficiency, but basically the idea is that we already have infrastructure to do this. So when you use Gmail and Google Talk or whatnot, we've had to build a bunch of scalable, efficient infrastructure. So you're piggybacking on that with App Engine.
Oh, we should plug Moshe's talk, though. So there's a talk sometime today. I think it's immediately after this, actually, that's going to go in a lot more detail about this. I don't know where it is or when, but I think it's immediately after this session. Want to start?
Hi. So I'm one of those guys who has a Grails running on App Engine.
Yeah, I'm sorry. Did you say a Grails app? Did I hear you correctly?
Yes.
OK.
And the initialization is basically killing us. It doesn't run as a result. So I wanted to know what are the plans to optimize it more. And also, I mean, that would be very, very helpful, I guess. What you can share and to make it actually work on the App Engine. And anything else that you can share with us now, please.
OK, well, so first of all, you want to make sure that you're using precompilation. So that's on by default. We're still constantly making changes in the background, and this is considered kind of a best effort thing. So occasionally, precompilation won't always take effect. But you want to make sure, you can get in touch with us if you want us to give you more information about your application, like the breakdown you saw in that graph earlier of GC versus hotspot versus whatever. We can share some information about that. We've also talked about some additional things beyond precompilation that we're planning to do, like increasing the parallelization of garbage collection and hotspot compilation. We think that'll be a pretty dramatic speed up, maybe on par with precompilation. And the I/O changes, depending on how much bytecode you have, that may be very significant as well. So like I said, we definitely have some things queued up. And those are the short-term things. We have some very long-term things queued up, too, that we're not quite ready to talk about yet. So it will keep improving. That's sort of one branch. And then parallel to that, we are introducing reserved instances as kind of a hedge, right? If its performance still isn't where you want it to be, then reserved instances let you pay for the privilege of not having to pay that cost, basically.
Go ahead.
Hey, so I just noticed you were talking about things you can do on the dev app server to try to create a similar environment to production, changes to the bytecode. Is that for only Java class files that are sitting, or can that also affect code generation that happens?
That should work for anything. So if you're running Rhino or Ruby or whatever, they all end up as bytecode in the VM. So that's the awesome thing about the JVM, right? You have all these different languages, and if you operate at the bytecode level, then things pretty much are great.
Okay, and actually, one other question I was curious. We're talking about precompilation is going to work for these classes that if you have a jar file that does a bunch of work, precompilation is going to help that. If you're using Rhino or JRuby or some other language that has a big runtime that's doing generation, that's not going to take advantage of that. Are some of these other languages looking at ways to do ahead-of-time compiling, or is that always kind of a challenge with different frameworks? I'm just curious generally how that works for.
Yeah, we can talk about that a bit more, but it depends a lot, like you pointed out, on the language runtime itself. Like, for example, Rhino has like both an interpreted and a JIT mode, right? And the JIT mode is faster and helps us like produce more bytecode and stuff like that. Actually, Charles Nutter has been working very hard to like produce to provide AOT compiling ahead of time compiling for JRuby. That's much more amenable to App Engine. Like right now, AOT compiling for JRuby just isn't great. It produces way, way, way more bytecode than it ought to and things like that. And so I'm really excited to see how the progress on that will come along for us.
Let's take a moderator question and then get back to you. Official Scala support. So I don't really know how to answer that question. We do have Scala support. I assume what this is referring to is things like Scala workers and different aspects of Scala.
Yeah, I'm not sure. What we do and what we have been talking about are making other language runtimes that are JVM languages more supported. So John has actually been working on that. Actually, several people have been working on that. So we might see, for example, maybe a Ruby runtime that is actually a JVM runtime. We might see a JavaScript runtime at some point. And so maybe we do something with Scala with that too. And typically these runtimes don't vary a lot, right? Because they're all using the same JVM backend. But there's like polish and fit and finish that you can provide around that in terms of like config files, like Ruby prefers more YAML-like files or something like that, as opposed to like, web.xml and App Engine web.xml files. So we don't have anything in the works planned right now for Scala, but really it has such great interop with Java. I'm not sure what we would do to improve it.
I'd like a full-fledged 2D API like Java 2D. What's the plan for that in the future?
We've given it a lot of thought. I don't think that we've invested a ton of effort into it currently, but it's definitely something that we've thought very hard about.
Right. We want it too. We want a full-fledged 2D API for App Engine. And again, like the problem with that is there's just tons of native code that is kind of that does like a lot of things like use, for example, graphics drivers and things like that. And so we have to be very careful to weave through that to make sure that we're going to provide something that's safe, right, like for everyone to use on App Engine. And so it's definitely on our plate, and we've taken like initial stabs and prototypes towards it, and it definitely looks like there is a lot of code that we can use that doesn't depend upon native code, but it's a pretty big effort. So any time for that, we don't want to promise anything right now.
Hi. So yesterday, according to the announcement about compatibility with VMware guys and with Google Application Engine for business at least, does this mean that you're going to create a separate infrastructure because probably the Spring guys and the VMware guys are providing support for threads, for example, or for Hibernate, for example, or things like this, which are more complete Java runtime environment?
Yeah, I don't really know how to answer that question. Let me try to repeat the question. The question was, with the partnerships that we announced yesterday with VMware and Spring, does that mean we will be supporting things like Hibernate? Is that basically your question? So
the question is it going to be compatible, really compatible between Google Application Engine and, for example, VM Cloud?
Right. Okay. So I don't actually know the answer to that question, to be perfectly honest. I know that the Google App for Business sort of product is definitely something that's going to be kind of composed of features that will be added to App Engine over time. And it's just kind of a way to tie them all together and provide a single price for them. But I don't know how that fits in with I know there was all the stuff talked about yesterday with interoperability across clouds. And to be honest, I don't know the answer to that.
Thanks. OK, do you want to go ahead?
Yeah, I'm actually looking at the manage static files from the app dashboard question, because I had the same question.
That's your question?
Yeah, basically, when we first did our requirements, and chose App Engine, we were just going to deploy the application part of our company's material on there. And it's a freemium model, so a lot of marketing material ended up in there too, which they want to change all the time. And I'm head of engineering, so we go through smoke on staging, we go through smoke on dev, and the marketing guy's like, I just want to change one file.
I guess the good news is that right now that if you do change one file and you redeploy your app, that really only re-uploads that one file. It won't reload all of the files in your application. Like the underlying way that works is we have a whole bunch of secure hashing schemes we use, right? And so we check with the server, does this file exist, blah, 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 blah. So it's not like, it's not really perfect, but you should get fast deploys anyway, right? You're really only uploading the content that changed.
If you really do want to dynamically, like on the fly, change this content, then you can think about making it part of your application instead of a static resource, right? If you can upload it to blobstore, for example, or just if it's small enough, upload it to the Datastore and serve it dynamically.
Right, that's a really good point. Like you actually have like CMS functionality, right, is different than just kind of static.
Absolutely, and this is kind of halfway there, kind of.
Okay.
Yeah. Thanks.
Okay, so what in JEE6 is supported currently or in the near future in App Engine? So I'm definitely not an expert in EE6. I know some of the things that includes like Servlet 3.0, and I know it includes new versions of like JAX-WS and JAX-B and all that stuff. I don't know if any of those versions that are new line up with the versions we currently support. I don't know that off the top of my head. But I will say, with respect to Servlet 3.0, specifically, we have a guy who works 20% time on our project sometime and was actually on the Servlet 3.0 spec committee. So it's definitely something we're aware of, and we've been talking to him occasionally about what it's going to require on our part. And it's something that we haven't begun on yet, but it's on the roadmap. It's definitely something we're thinking about. Okay.
All right. I think, did we run out of time here, or are we done?
We're
they're
over.
cutting us off. So thank you, everyone, for coming to the presentation. Hope you enjoyed it.